Hi, this is Mr. Snyder with Truman Middle School, and today we are going to learn to solve equations with variables on both sides of the equal sign. Some problems produce equations that have variables on both sides of the equal sign, so we will treat that similarly to the way that we did yesterday. Solving an equation with variables on both sides is similar to solving an equation with a variable only on one side. Our mission is still the same, to get all the variables on one side, all the other stuff on the other, so that we can isolate the variable. And the rules are the same. You can add or subtract a term containing a variable as long as you do it on both sides of the equation to keep it balanced. So let's look at an easy example. Notice in this example, we do have x's on both sides, so we need to move the x's all to one side. So in order to do this, I can simply subtract 4x from the left-hand side. But if I subtract from the left-hand side, I must also do it to the right-hand side. So the x's on the left cancel out, leaving me 6 on the left side. A positive x minus 4x would leave me with a negative 3x. And to finish this, simply divide by the number that is stuck to the variable. In this case, it's a negative, so I must divide by a negative 3 on both sides, and that will give me a result of x equals negative 2. And remember, you always have the power to check your solution by substituting the value back into the original equation. This usually requires 3 lines of work: the original equation, the substitution, and then showing the equality. Let's look at one more example, then we'll do the problems in the note packet. So notice we have b's on both the sides and we have numbers on both the sides. So let's go ahead and move all the b's to the left. So I'm going to get rid of my 5b by subtracting 5b from the right and also doing it to the left. That leaves me with 4b minus 6 on the left side and 18 on the right side. So now I need to get rid of the minus 6 the same way that we did it yesterday. So we simply add 6 to both sides, and the result would be 4b on the left, 24 on the right. It is now a one-step equation that we can solve by dividing both sides by 4. Thus, the solution would be b equals 6. And remember, I can check that by rewriting the original problem, plugging my answer in for b, and making sure that both sides end up equal. That verifies that we do have the answer correct. So let's go ahead and do some of the problems out of the notes. Let's look at the first one. The first one, we have 2a plus 3 equals 3a. So I'm going to get rid of the 2a by subtracting both sides by 2a. So subtract 2a from the left, subtract 2a from the right. My a terms cancel out. I'm left with 3 on the left. And on the other side, conveniently enough, I'm left with just a. A equals 3. And remember, you could check this by rewriting the problem, plugging in your answer for a, and making sure both sides are equal. Let's look at the next one. Now we have numbers on both sides as well as variables on both sides. So let's go ahead and get rid of the 3v. We'll start by doing that. So in order to get rid of the 3v, I subtract 3v from the left. I subtract 3v from the right. These cancel out on the left, leaving me with just a minus and an 8. And then on the right-hand side, I have 7 plus 8v minus 3v, which is 5v. So I'm almost there. I still need to isolate the variable, which means I need to get rid of the 7. So the easiest way I know to get rid of a 7 is to subtract 7. And do that to both sides. Be careful of your signs, because a negative 8 minus 7 more is really the same as adding 2 negative numbers. So the result would be negative 15 on the left. My 7s would cancel out, and then on the right I have 5v. So now it's a one-step equation that we can finish by dividing both sides by 5. So on the right I have v, because my 5's canceled. On the left, be careful of your signs. A negative divided by a positive is a negative. In this case, negative 3. So v equals negative 3. The next one, g plus 7 equals g minus 3. So I need to get rid of a g, so I subtract a g from both sides. And something unique happens in this instance. My g's cancel out, and I end up with 7 equals negative 3. Anytime my variables cancel out like that and I end up with a false statement, such as 7 equals negative 3, this is an example where there is no solution, because obviously 7 is not equal to negative 3, so I could simply write no solution. There is no number I could put in for g that would make this equation work out. So no solution on that one. So be careful of that type of problem. Moving down to a more complicated example. We have a lot of terms in this example, so let's start by combining like terms. 2c minus 3c is going to be negative c plus 4, just by combining like terms on the left. Negative 9 plus 5 is going to be a negative 4 plus c. So I only combined like terms. I haven't moved anything at all. Now I will move some things. I think I'm going to move that negative c. The best way to get rid of a negative c is to add a c to it, and they will cancel. But if I do it to the left, I must do it to the right. So now I have 4 on the left, negative 4 on the right, plus 2c. So my mission now is to get rid of that negative 4, so I'm going to add 4. But if I add 4 to the right, I've got to add 4 to the left. I get 8. These cancel, and I'm left with 2c equals 8, which is a one-step equation that I can solve by dividing by the number stuck to the variable. So I get c equals 4. And again, I could check my answer by simply plugging in my answer into the original equation. I know this next one's a little bit blurry. Let me see if I can zoom in a little bit more. Maybe that helped, maybe it didn't. So yesterday we talked about clearing out a fraction. So we need to find out the LCD of 3, 6, 4, and 9. So the LCD of 3, 6, 4, and 9, the only number that I can think that all of those will go into is, I believe, 36. So I'm going to multiply this whole thing by 36, and that's going to clear out my fraction. The key step to this is writing down each individual piece, showing the distributive property. So I have 36 times 2w over 3 minus 36 times 5w over 6 plus 36 times 1/4 equals, I'm sorry, I'm running out of room, 36 times w plus 36 times 11/9. And I know this is a hassle to write all this out, but this is the best way you can ensure good bookkeeping. So now let's cancel some things out. I can divide out a 3, and that goes to 1. If I divide 3 into 36, I get 12. My next term, a 6 will go into both 6 and 36. So 6 into 6 is 1. 6 into 36 is 6. My next term is 36 times 1/4, so I could divide out a 4, and I get a 1 there. If I divide out a 4 here, I get a 9. 36 times w is just going to be 36w, so let's skip to the last term. I could divide out a 9, and I get a 1. Divide out a 9 for 36, and you get a 4. So let's clean this up and rewrite it. 12 times 2w is going to be 24w minus 6 times 5w is going to be 30w plus 9 times 1, which is just 9, plus, I'm sorry, let me erase that because that's my equal sign there, not a plus. So let's go ahead, put my equal sign there. 36 times w is just 36w. And then lastly, 4 times 11 would be 44. So it took a little bit of work, but now it's a lot more cleaned up. So let's go ahead and finish this. Combine like terms. 24w minus 30w is negative 6w plus 9. Over here I have 36w plus 44. So I think I want to get rid of that negative 6w by adding 6w, and I'll do that to both sides. So running out of room here, but I'll scroll down a little bit. These cancel out. I'm left with just 9. Over here I have 42w plus 44. So the last thing I need to do is get rid of my 44. So subtract that from both sides. Those go away. I'm left with 42w on the right side. 44 minus 9 would be 35, but the negatives win that battle. So I have 42w equals negative 35. Last step, divide by 42 on both sides. And this isn't the best answer. Isn't the answer I was really hoping to see, but sometimes answers aren't pretty. So the answer to this would be negative 35 over 42. And if I divide out a 7 and simplify, this would really be negative 5, 6 equals w. And remember, I could plug that into the original equation to check it. So that's it. Go ahead and look through these problems, rewind if you need to, because this is a little bit tricky, especially that last problem. And if you have questions, don't hesitate to ask tomorrow.